Hi everyone, this is Mr. West. We're doing a Khan Academy tutorial on converting recursive and explicit forms of arithmetic sequences. Let's go ahead and start. We're given h of n equals negative 13n, and we're asked to complete the recursive formula of h of n. So essentially what we're doing is we're being asked to convert this explicit sequence, this explicit formula, into a recursive one. So let's break down a couple things. Number one, okay, if we have an explicit formula, we know it's in this form. You can write any sort of linear or arithmetic sequence in slope-intercept form, okay? So slope-intercept form is y equals mx plus b. Now, a recursive formula uses these components. These components are h of n. That's the current term, okay? The current term is h of n. So n minus 1 is simply the previous term. So if we're talking about, for example, the second term, okay, that's our current term. So minus 1, 2 minus 1 would give us the previous term. See that? That's the term before it, okay? So n minus 1 is the previous term. Now, finally, we have h of 1, and that is our first term. So if we have a 1 in that spot, that means we're talking about the first term. So it gives us the first term as a blank, and then we're asked to figure out what are we adding each time. Once we have our previous term, okay, so 1, once we have that, what do we add each time to keep the pattern going? This is basically how you break down a recursive formula. So this will always tell you, a recursive formula will always tell you, first, the previous term. Okay, recursive means you have to act on the previous term. Okay, and then you have to have some sort of change to get to the next term. So some sort of change happens, okay? Now, h of 1 is pretty easy to find out. We just have to plug in 1 into n, okay? And it goes in right there. So we're going to put in h of 1 equals negative 13 times 1. That gives us negative 13. So we have our first term, it's negative 13, okay? Now, in order to figure out what the pattern is, okay, we have to, keep plugging in. So we could plug in 2 to find out what the second term is. So we plug in 2, we get negative 13 times 2, and we get negative 26. Okay, so negative 26. Recursive formulas need the previous term, and then we figure out, okay, what do we add to get negative 26 from negative 13? And the answer is we added a negative 13. That is our change. Okay, so we're talking about slope-intercept form up here, explicit formula. The m is the change. Okay, so if we saw here, this is our m. That 13, that negative 13, that is our m. That is our change each time. Okay, notice how you say, okay, well, I don't see a plus b. Okay, well, that b is the 0 term. You have to go backwards to find the 0 term. Okay, so here's our 0 term. We'd subtract at 13 from whatever the 0 term is and get negative 13. Well, the 0 term is going to be 0 in this case, okay? So this one's kind of an odd duck just because it doesn't have a 0 term, doesn't have a y-intercept, but we got the components that we need. Number 1, we have h of 1. We know that's negative 13. And then number 2, we know what our change is. We know that we're subtracting 13 each time. The number being multiplied by x, whoops, not sure why I erased that. Then we're being multiplied by x, okay, right here, or by the variable is always your change. That negative 13 is your change each time. So we can look right there. We don't have to do as much math as I did. We see that let's change it by 13, negative 13 each time. All right, next question. Okay, we're asked to find an explicit. We're given the recursive this time. We're asked to find the explicit formula, okay? So let's break down a couple things. Number 1, we're given the first term. We need that, okay? For recursive formula, we need the first term. So we know that 1 is negative 75, okay? Now, with this, we're given the previous term. I already said that. Previous term is always that n minus 1. And we're also given the change. What do we do to that previous term to find the next one? And it says subtract 10. So we know that the next term is negative 85, okay? We know the next term is negative 85. But the most important thing is that change. That change is minus 10. So if we're talking about slope-intercept form, okay, remember we had y equals mx. Don't forget the plus, and then we had the b. That's the 0 term. And then we had this, which is the change. So the change was minus 10. So we're going to multiply that by our variable. In this case, it's not x, it's n. Okay, so we have negative 10n. And now we need to find the 0 term to round off this equation. So to find the 0 term, again, we go backwards. So instead of doing the change each time, minus 10, we need to go backwards. Go this arrow, or just think to yourself, okay, something minus 10 equals negative 75. Or to go backwards, you add 10. Okay, opposite of subtract 10 is add 10. Either way, we get negative 65, and it should complete the pattern, okay? And this would be negative 95 over there. So again, the 0 term in this case is minus 65 or plus the negative 65, and that's going to be equal to y, or in this case, h of n. So we should write this as h of n, not y. H of n is equal to negative 10n minus 65. Negative 10n, and we got that from that minus 10 up here. The change, let me highlight it, the change minus 10, and then minus 65, because we went backwards and found the 0 term from the first term that it gave us, and we'll check that. Okay, next question. Complete the recursive formula. Well, we have a couple things we need. Okay, we have our change. The change is always the number being multiplied, okay, in front of the variable. So in this case, here's our change. Our change is 4. So it's going to be plus 4 because it's a plus 4 right there. So plus 4. Okay, that's the first and easiest thing. And then we're going to find our first term by plugging in 1. That's all we need to do. So if we're looking for f of 1 in this case, and this is the usual designation for recursive formulas, okay? So we plug in 1 since we're looking for 1. Here's the 1. Here's the n. There's the f of 1. Equal to, and then we're going to say 93 plus 4 times, and this is where we plug in the 1, okay, minus 1. Well, this part's kind of easy. We do 1 minus 1, that's 0. 4 times 0 is 0, so we're just going to end up with 93. That goes away, and we're left with f of 1 is 93. Okay, next question, probably the last. Find the explicit formula. This one I'm going to make easy. So let's find the change first. The change is 2. Okay, we see that it's the previous term plus 2, so we know it's 2. 2 times n. Again, we're thinking of slope-intercept form. The change is the same thing as a slope, so it's 2 times our variable n. Okay, f of 1 is 0. This is where it helps a little bit to write it out. F of 1 is 0, so f of 1 is 0. We know we're adding 2 each time, so our second term would be 2. So if we want to go backwards, we're going to subtract 2. F of 0 is going to be minus 2. So it's 2n minus 2, and that's going to be our explicit formula. Bada bing, bada boom, and we're done. And that's all there is to it. That's converting recursive and explicit forms of arithmetic sequences. Hope you enjoyed this video. Let me know if you need any other videos covered, especially on arithmetic, recursive, explicit forms. And I look forward to seeing you next time right here on West Explains Best.